Okay, so we have n applicants and m free apartments. Now there are two decisions that we need to make. First, which quality will match to which other quality? What does that mean? It means that I need to decide if I should match the apartment to the applicants or the applicants to the apartment. Right? Now thinking about it, how should we approach this problem? So let us go with this. First, we need to sort each and every apartment and applicant. With this, I know that the first applicant which I have requires the smallest possible apartment. So there can be equal applicants, but I don't think that will be of any problem to us. So let us take it this way. Since I know that this person is willing to accept a apartment of size less than of size that will be k less than his requirement and of size that is k greater than his requirement. It means it gives me an intuition that I need to do or I need to search in my apartments the smallest suitable apartment. And how will I do that? It is simple. I will do a binary search. Now, what type of binary search should I do? For that, I need to make sure that the type of apartment that I am looking for, it should be a apartment that is it is larger than the minimum requirement that this guy has. So instead of searching for the direct apartment, so instead of searching for the exact apartment that this guy is looking for, I will search for the smallest apartment that he is willing to accept, which will be x minus k. So I will do a binary search on this apartments, and with that binary search, I will do a lower bound. Now, this lower bound will give me 60, right? That 60, there are two possibilities in this scenario now. Either the answer that I got, wait, let us first clarify what is lower bound. Lower bound will be equal to that number or greater than that number, which will be equal to 40 or greater than 40. So the answer will be either equal to 40 or it will be greater than the 40. Now what I have obtained is 60, which is of course greater than 40. Now I need to make sure that that value, which is 60, is should be within this range 40 to 50, which means since I already know that this value will be greater than 40, I just need to make sure that 60 is less than 50. 60 is less than its upper limit, which is x plus k. So the code will look like this. Let us go for lower bound of the array, comma x minus k, and let's store this in a iterator. Now this iterator, whatever value it has, I will check if iterator is not equal to end. If it is equal to end, that means there is no apartment to be allotted, right? Next thing what I will do is I will uh, check if the value in iterator, which I will get by doing star of the iterator. Now if you want me to go into the technicals of how we get the star, the addresses specifically, we can do that later. Of course, I'm open to that discussion as well, but for now let us focus on this solution on this problem. Now once I got the value, I will check if the value is less than, should I go for equal to, yes, or equal to the x plus k, then I will say allocate plus plus, which is I found one allocation, and I will delete the iterator, and I want to delete the iterator. Now, once the iterator is deleted, what I will do is I will have stored the apartments in a set. Should I go for a multi-set? Yes, I should go for a multi-set. In a multi-set. Now, with this delete, I know that the iterator is gone, which means 60 is taken, and my set will have 30 and 75. I will do this for all x in what is that applicants, and I will return allocate whatever this value is. So now let us code this. CP. So this is graph. I think I have done revision, sorting, and searching. Wait a minute. Well, that is interesting. So I have already done this question, I believe, which is apartments, of course. And this is the code for apartments. Yes, I took the lower bound. I took the lower bound from the multiset, which is odd. I should not have done that. And so I think V is the requesters, right? And I sorted V. Yeah, that's right now. I sorted V. Then I inserted all the apartments in a multi-set. Now I'm removing from that multi-set by doing search over it, and I'm returning the C. So this is the exact code that we discussed just now, right? So I'll be moving to the next question, or since I'm pretty sure how to do these questions, I'll go to the Ferris wheel part. So we have done that in 7 minutes. That is a big achievement for ourselves now. Let's take the Ferris wheel question. So there are n children who want to go to a Ferris wheel, and your task is to find a gondola for each child. Now each gondola may have one or two children in it, and in addition, the total weight in a gondola may not exceed X. You know the weight of every child. Okay. What is the minimum number of gondolas needed for the children? Hmm. Okay, let us stop sharing and end this stream.